This is the largest AI cluster in the world. A supercomputer with 200,000 GPUs, 16 quadrillion transistors, exabytes of storage, and super-fast networking, located in Memphis, Tennessee, in the United States of America. This is Colossus, a supercomputer built by Elon Musk's xAI, used to train the smartest AI on the planet, which is Grok 3. Hello everyone, welcome to this video. The story of building Colossus is really interesting. In a race against time, Elon Musk's xAI team faced many challenges to build Grok 3. In this video, we will see how they battled entropy, power chaos, and engineering nightmares to create an AI that rivals the best. Back in 2023, while international players like OpenAI were shocking the world by announcing their flagship GPT models, there was tremendous pressure on xAI to launch a rival AI. The timeline was strict. The team had to build a supercluster on which Grok 3 could be trained. In the first phase, this supercluster comprised 100,000 NVIDIA H100 GPUs, and the plan was to increase this number to 200,000 in the second phase. The xAI team approached data center provider companies to set up this huge cluster, and they were given a timeline of 18 to 24 months. For Elon, that was not accepted. The team decided to do it themselves and completed Phase 1 in just 122 days and Phase 2 in another 92 days. First, they acquired a 785,000 square foot facility in Memphis, Tennessee from the Electrolux Group. They repurposed this abandoned Electrolux factory as the home of the supercluster. This is the data hall of this supercomputer. And below the floor, we have huge cooling system pipes. In this data hall, this particular section is called mini cluster. The data hall has approximately 391 mini clusters like this. Each mini cluster has 8 racks manufactured by Supermicro Company. Each of these racks contains 8 HGX H100 platforms. This platform you can understand like motherboard of your computer on which your CPU is installed. Each of this platform has 8 NVIDIA H100 GPUs installed on it. H100 GPU is most powerful GPU in the world, manufactured by NVIDIA in 2023. That means each rack has 64 GPUs, and each mini cluster has 5 RIM12 GPUs. With 391 mini clusters, the total comes to 3,928 racks and approximately 200,000 GPUs. This is really insane. Hope you get an idea about how big this cluster is. At the bottom of each rack, there is a CDU, which stands for Cooling Distribution Unit. The CDU is connected to the central cooling system. It pumps cool water to NVIDIA platforms, which keep all GPUs cool and send the hot water back to the CDU. With each of these platforms, you can see blue and red pipes. Blue pipes carry cold water, and red pipes carry hot water. Now let us go to the back side of this racks. At the back of these racks, there are many fans and network elements. The question is, if the GPUs are liquid-cooled, why are these fans needed? Well, the liquid cooling system only cools the GPUs, but to maintain the overall temperature of the rack and cool down other components like memory, these fans are required. We have a heat exchanger in the rear doors of the racks. It passes hot air from the internal fans through the radiator and flows cool air back into the rack. The blue lights you see in the heat exchanger are not just for aesthetics. They indicate that it is working fine. If any of these units have an issue, they light up red. So, simply by walking through the passage, engineers can easily identify faulty units and fix them. This is a really smart idea. When all these GPUs, fans, and pumps work together, they produce a humming sound like this. You might imagine how complex the network of Ethernet cables must be to connect all these components and make them work together. So far, this was all about the data hall. Now, let's go to the lower floor, where we have huge pipelines for hot and cold water. These pipes bring cold water from the cooler and supply it to the cooling distribution unit of each rack on the upper floor. They also take back the hot water from the cooling distribution unit and send it to the cooler. This is a great example of reusability. Now, to run this giant beast, we need 250 megawatts of electricity. But the challenge was that the factory's existing power supply was only 15 megawatts. To fulfill the power requirements, xAI lined up the factory with hundreds of diesel generators. This supercomputer is like a symphony of 200,000 participants. When all these GPUs start and stop within milliseconds, there are huge fluctuations in the power supply, which can damage the generators and the power grid. To solve this, xAI reprogrammed Tesla's battery system, called Megapacks. All the power from the grid and generators is used to charge these huge batteries, and the cluster uses power by discharging the batteries. This prevents any damage to the grid and generators due to power fluctuations. Training a model of this scale meant fighting cosmic rays. Quadrillions of transistors and thousands of GPUs process exabytes of data bit by bit. What an amazing thing this is. After all this complex engineering and hard work, the result was a model that redefined AI. That's it from my end for this video. Hope you enjoyed it. I really appreciate your support by sharing and subscribing to my channel. That gives me so much motivation to create content like this for you all. See you in another video. Until then, happy learning.